Hello everyone, welcome to Diksha Karnataka YouTube channel, and today I am going to start a new series, new session, Sankalp KCET 2026. And if you are someone who are preparing for your KCET or JEE journey for your upcoming 2026, then definitely you must watch this series. Here we will be covering mainly the theory of all the chapters. Also we will be covering the previous year questions from KCET as well as previous year questions of JEE. So if you are someone who is preparing for KCET, JEE, then definitely this is a must watch series for you. And Sankalp, which translates to determination. So if you are determined to succeed in your life, then definitely this is a must watch series. And I know physics is one of the difficult subjects for all of you, and many of you struggle in physics. So here I am trying to help you to achieve the maximum possible marks from physics. Now, as I said, today I am going to discuss electric charges and field, and first part, electric charge and field, will be our first part of discussion. But before I go into our chapters, let us show you our achievement. Here are few of the students who studied from us through our YouTube channel and see their achievements. Okay, here we have the toppers from our last year 2025 KCET batch, and you can be one of them in the upcoming year 2026. So if you are if you want to feature in this list next year, then definitely you must follow our YouTube channel. We are not only doing physics, we are also doing chemistry, we are doing mathematics as well as biology for those who are having that subject as well. So all the subjects will be covered in our channel, not only for your competitive journey as well as your PU2 journey as well. As you know that for KCET exam, PU2 marks are super important. So here in this series we will try to cover everything together. Some, obviously the focus is more on competitive sides. We will cover PU exclusive PU content for later on, but right now, even if you are studying for CBSE, then also you can watch this series, because we are covering all the common syllabus for PU, CBSE and other state boards as well. So without any delay, let us start with today's chapter. So first let us understand what is the chapter electric charges and field consist of. What are all the concepts, what are all the important topics, and if you study all these concepts, how many questions you can expect in KCET exam. So first of all, obviously the first concept from this chapter is electric charge. Now based on the concept of electric charge, you can divide into conductors and insulators. There is semiconductors as well, but semiconductor we will not cover in this chapter. We have basic properties of charges as well. Then we have Coulomb's law. Okay, there are two branches. In one branch we have conductors and insulators, okay, and we have basic properties of charges. And from the second branch we have Coulomb's law, electric field lines, properties of electric field lines, etc. And this entire thing I will cover in today's lecture. This entire thing I will be covering in today's lecture. And in upcoming part 2 of the lecture, I will be covering electric dipole moment, electric field due to a dipole in an external field. So entirety of this thing will be covered in our part 2 of the video. And in the part 3 of the video, we will be covering electric flask, charge distribution, Gauss's law, and application of Gauss's law. Everything will be taught in detail so that we do not miss out on any single opportunity. All the important concepts, important formulas will be discussed in this series. And if you want to get the PDF of this lecture, then definitely you have to join our WhatsApp channel. Link of that is given in the description, so don't forget to join our WhatsApp channel. So let's start with today's topic. First obviously is electric charge. As we said, you have a basic idea of electric charge. You've studied electric charge I think in your 7th or 8th class based on what board you are on. Now first let's see. In physics, charge refers to the fundamental property of matter that causes it to experience an electric force when placed in an electric field. Now, electric field concept I have not yet discussed, but this is the basic definition of electric charge. I will come back to electric field later on, but for now, charge. Okay, charge refers to something which experiences a force when it is placed in an external electric field. So if you keep it something which in an electric field, you know this is an electric field, I keep something, if it is experiencing a force, that means if it is moving, okay, so either it is moving right or left, up and down, no matter what, if you just keep it without any motion, you keep it, which is very, very important. If you keep it, if it is experiencing a force, now how to measure if it is experiencing a force? The measurement is it will try to move. It will try to move. That is the sign of experiencing a force. Right? For example, you are standing on a road, someone pushed you, so you are experiencing a force. Why you are experiencing a force? Because as soon as someone pushed you, you tend to move. Okay, now maybe you just balanced yourself and come back to your original position, but because your body reacted to that as if you are trying to move, that means a force applied on you. Right? So force, application of force means the object will tend to move. Okay, there are two types of charges. Obviously we all know there are two types of charges, positive charge and there is a negative charge. Now we in detail about these charges we will discuss in a while, please wait till that time. And also there are one more property of the charge, that like charges repel each other. Like charge means the charges which have the similar types. Similar type charges are called like charges. For example, two positive charges. Okay, two positive charges are called like charges. Okay, positive are called like charges and negative are also called like charges. These are called like charges. Okay, when charges type are similar, they are called like charges. Okay, and unlike charges attract each other. What is the meaning of unlike charges? Unlike charges means one of them is positive, another one is negative, or one is negative, another one is positive. Okay, so as you can see here we have if the charge sign is opposite, they will attract. If the charge sign is same, they will repel each other. So this is a very basic fundamental thing about charges. Now let's see slightly more detail about it. In a neutral object, positive and negative charges are balanced. Neutral object means most of the objects that we see around us are neutral. Okay, even you, me, okay, this pen, they are all neutral, right? So neutral objects means those who does not have, we call in other way, we call it excess charge. Okay, it does not have any excess charge. It is electrically neutral. Now how to know that something is electrically neutral or not? If you touch something and if you don't get an electric shock, that means that is an electrically neutral object. Okay, mostly. There are other cases also there where you may not get a shock, but that is a complete different scenario. I am not going to discuss that. But if you are generally, if you are not getting an electric shock or your body does not react to it, for example, if you touch a Van de Graaff generator, your hairs will stand up. Okay, that is also a charged object. So in some cases your body reacts to it, that means this is not electrically neutral. Okay, you may not get a shock in case of Van de Graaff generator, but your hairs will be standing up. So there in one case or another, if you see something is happening, that means it is electrically charged. If nothing is happening, that means it is electrically neutral, right? So all the objects which are electrically neutral, they have equal number of positive and negative charges. Neutral object does not means it is void of charges. Void of charges means total charge is zero, obviously, but that does not mean that it does not have any charges in it. It still has charges. Okay, Neutral object means it still has charges in it, okay, but in this case number of positive charge is exactly equal to number of negative charge. That's it, and we call it a neutral object. Okay, total charge is 0, but that does not mean that it does not have any charge in it. Okay, to charge a neutral object we need to add or remove one type of charge. Very important point. Okay, to charge it, if I want to say I want to charge it positively or I want to charge it negatively, so how can you make it charge positively or negatively? To do that, you can only add or remove one type of charge. There are two types, positive and negative. Out of the two types, only one type of charge can be added, or one type of the same type of charge can be removed also. Okay, the only electrons can be added or removed. Now that type of charge is called are known as electrons. We'll see that electrons are basically negatively charged particles, very small tiny microscopic particle. Okay, not even microscopic, you have a special type of microscope to detect them. Okay, subatomic, we can say subatomic particles. So they are very tiny subatomic particles, very small. So negatively charged electron, so this is the electron. So whenever I say negative charge, that means it has some electrons in it. Okay, so you can basically remove or add this negatively charged portion of the object. Okay, so if you add some electrons in it, okay, then what will happen? The object will become negatively charged. Okay, negatively charged. Object will become negatively charged. And if you remove some of the electrons, okay, then it will become, so if you remove some electrons, then it will become positively charged. If you add some electrons, then it will become negatively charged. Okay, very interesting, right? Generally adding means positive, removing means negative, but in this case you are removing negative charge only. That's why you have to, even though the concept is easy, sometimes you might get confused if your basics are not cleared. Students often skip these concepts, and in the exam there are some easy questions just asked in the indirect way, and you fell victim of it because you don't know what is the positive and negative. These concepts will be very handy in future, may not be right now, but in future there is one chapter, magnetic electric charges and magnetism. In that chapter there are a lot of questions that comes. The chapter was based on positive charge, but they ask you based on negative charge. So if you are not sure about positive and negative charges, in that chapter you will struggle because you lack the fundamental clarity. Okay, so only electrons can be added or removed. No, nothing else can be added, nothing else can be removed. Okay, so electrons are negatively charged. So as I said, electrons are negatively charged, and only negative charge can be added or negative charge can be removed. Okay, so if electrons are added to a body, it gets negatively charged. If electrons are removed, the body gets positively charged, right? So if electrons added, body gets negatively charged. If electrons are removed, the body gets positively charged. Okay, let's move on. Gold leaf electroscope is a device that can measure the presence of charge. So if for example I said if you touch something, it reacts, right? Your body reacts or something, you get an electric shock, something like that. But if the charge is very small, your body may not be able to react to that small amount of charge. Now how can you still detect if the object is charged or not. For that, obviously we have to have some instrument, and that instrument is called gold leaf electroscope. This is a schematic diagram. Gold leaf electroscope actually does not look like this. It can have different designs, okay, but this is a schematic design. Okay, here we have a gold leaf. Gold leaf means very thin strip of gold, as if it is as thin as a leaf. Okay, leaf of a plant. Okay, very thin piece strips of gold. It is bent like in U form. Okay, and it is basically not bent. Actually, there are two strips. Okay, two strips cut and they are hanged from here. Okay, if you brought a charged object near it, okay, the leaf petals will repel. Okay, if it is charged, okay, if it is charged, it will repel, and if it is neutral, it will not repel. There are some ways how can you determine the type of charge, nature of charge, how to charge a gold leaf electroscope, but those are no longer part of the syllabus. Maybe you have studied something about that in your lower grades, but how to charge a gold leaf electroscope is used to be in the part of the syllabus long back, some 5-10 years back. Now it is no longer part of the syllabus. Okay, now SI unit of charge is Coulomb, and it is denoted by capital C. Okay, small Coulomb. Obviously, Coulomb is name of a someone who did some experiment in physics. Coulomb's law is after him, obviously. So he is a person. So as you know that if you write the first letter capital, that gives you the name of the physicist or the scientist. That does not give you the unit. For unit, you have to write it in the small letter or only capital C. That is sufficient. Right, so I hope you are already aware of it. So SI unit of charge is Coulomb, and also the dimension of charge, as you know, if you have slightly little bit remembering from your first chapter units and measurement, there are 7 fundamental quantities, and charge is not a fundamental quantity, but current is a fundamental quantity. So the dimension of charge is A into T. A is ampere, that is current, and T is time, right? So this is the basic overview of electric charge. Now let's move on to the next part, where we are going to discuss about conductors and insulators. Okay, most commonly conductors and insulators are basically defined in terms of whether it can conduct electricity or not, right? That's how we define the conductors and insulators. There is a basic fundamental thing that can determine whether it will be a good conductor or it will be a bad conductor. There is also heat conductor. Heat conductor is almost same as conductor in electricity, but there is slight difference. But anyway, heat conductor we are not going to discuss. This is electrical conductor, obviously, who can conduct electricity better. Okay, so let's see one of the image of a conductor. Here you can see a cross-sectional image of a conductor where a lot of wires are going through it, and there are some insulating covering around it. Okay, charges. Now what is the basic definition of conductor? Charges can freely move through them. If charges can move through them freely without getting affected too much, then we call it a conductor. Okay, a conductor has a lot of free electrons to carry the electricity. So that's what I was saying, that even though we say that conductor means which can carry electricity, which can carry current, but how it can do so? Because conductors already have a lot of free electrons inside it. Okay, so lot of free electrons which can carry the current on top of it. So basically it's like a river full of you can say boats. Okay, electrons are boats, and the conductor itself is a river, and the boats can carry the current through it, right? So if you want to cover a river, if you are someone who stay near a river, okay, Kaveri river or any other river, okay, you may have experienced it that when you want to cross the river, you have to take a ferry or you have to take a boat. Okay, so when you are crossing that river, you have to take the ferry or you have to take the boat. So basically that ferry is carrying people from one side to another. So the same thing is done by the conductor. Conductor is basically is also the river as well as the boat. Okay, so the boat carrying people from one side to another, and the people which are they people are basically the current, and the boat is the electron. Okay, you can think it like this. So more visualization you do in your brain, it helps you to remember. Okay, I just gave you one visualization. Now if you can do more visualization, that is up to you and you can remember it. I like to remember through visualization because obviously physics is a slightly boring subject. If you don't visualize concepts on your own, then you might feel lost in the curriculum. But if you remember, okay, conductor is basically like a river through which boats are flowing, so that is how you can remember it. Now metals, graphite, metals are all the metals are good conductors, okay, and graphite, even though it's a non-metal, it's a good conductor. There are some other examples as well, and if you know any other examples of metals, obviously don't forget to mention that in the comment below. Charges given to a conductor always lies on the surface of the conductor. So if it is a conductor and if you give it some charges, the charges will always lie on the surface of the conductor. So if you give it some charge, say you give some negative charge to it, the negative charge you added here, the negative charge will no longer stay here, but it will come to the surface of the conductor. That is the beauty of the conductor. Okay, so whatever charge you give, they will always stay on the surface of the conductor. Now if you cut a wire that carries current, you will see that they have not a single solid core, but they have lot of small wires combined together, right? You have seen that, I hope. Most of the people at your age should have seen inside of a wire. Okay, now why do you think that these wires are cut like this? The wires are made like this. Okay, why there are lot of single strands instead of having one single core? There are multiple reasons, but one of such reasons is explained. I have explained it, but I have not directly pointed it out. So if you know that answer, also mention that in the comment below, that why a wire is made up of a lot of threads instead of only single core. Okay, now conductors and insulators. Now let's look into the next part, that is insulators. Now insulators are those where basically obviously the current does not flow, right? So insulators our charges cannot flow through them. They have almost zero free electrons, and examples are plastic, paper, non-metals, etc. So now if you see that here we have a pole, electric pole. Here the electric pole is made up of not a metal, but it's made up of first of all wood. So this is also a non-conductor or insulator. Okay, sometimes insulators are also called non-conductors. Okay, conductors, non-conductors, conductors, insulators. Okay, so you should be familiar with this. Now this is very simple. Now in the city areas, you may have seen that these poles are not made of wood. They are also made from metals. Right, very common in cities and most places that you have seen, the poles are made from metals, aluminium or iron, okay, or alloy of iron. Okay, that's how these are made. But have you ever wondered, if you touch that pole, will you get electrocuted? Have you ever wondered? Have you ever thought, it came across your mind multiple times? Some are basically very afraid that, okay, if I touch it, I will get electrocuted. Some with curiosity have touched it also and say, oh, nothing is happening. Right? That means electricity is not passing through this, or you are thinking that there is a ground, so the current is directly going to the ground, but I am not getting electrocuted. No, nothing like that is happening here. So let me explain it to you. So electric poles are generally made from metals, and if they are dangerous, then definitely they are not built like that. They are built nowadays, right? So if they are dangerous, then definitely the people will, the government or the electricity department will not leave it alone like this. They would have covered it, they would have written danger, don't touch, 440 volts, etc. like this on the poles, but that is not happening. So that means they are quite safe, right? Unless and until there is some leakage or there is a raining and with thunder. In case of thunder, the poles are even poles and also the large trees, they are very vulnerable. They can attract the thunderstorm, thunder lighting, and that can cause a fatal damage to it. So during the lighting, you should stay away from poles, from high rise, high trees, etc. Right? That is general precaution. That is not only for electric poles, that is for all high standing structure like this. Okay, now why it is so? Why the poles are normally safe unless there is a cut, unless there is some electric line which is snapped due to some accident. Normally they are very, very safe because they have a very beautiful thing, this. You have seen this, right? And you are thinking, what is the use of these things? Okay, these are used in, I used to stay somewhere where the railway line used to pass, and it is very common in the railway lines as well. All the railway lines, if you see that where there are electric railways, where railways are basically done through electricity, okay, not diesel engines. Electric engines are very common nowadays. For example, Vande Bharat, etc. They are all run in electric engines. So electric engines are very common. There you will see a lot of these. Now what are these things? They are basically insulators. They are insulators. Okay, and the electric high tension line which carries the current, they are not connected to the pole directly. Okay, they are connected to this insulator. They are connected to this insulator. Okay, again the same thing is happening over here also. The insulator is connected like this. Now you will see, say, sir, if they are connected to insulators, how the current is getting carried from this end to the other end? That is done by this wire. Okay, this wire, what they do, the current comes over here, and instead of passing through the pole, okay, they are basically passed like this. Very easy, simple, right? And these insulators, they basically insulate the pole from the high tension electric wires. That's why even if you touch the pole, there will be no leakage, unless somehow, suppose this wire got snapped and they wrapped around the pole and the pole itself is electrocuted, then you might get a shock. Okay, that is a fatal accident. That during rainy season in a lot of places it is very common. So during rainy season and during storms, etc., you should stay away from poles. Otherwise, in general 99% cases, these the poles are completely 100% safe. Okay, but not always. As I said, there can be some accidents, so try to stay away from poles. Okay, don't go near them because they are carrying high tension electric current, right? Anyway, so this is how I explained it. Next, there is a third type of conductor called semiconductors. Now semiconductors, I am not going to discuss about it. Their conductivity depends on temperature. Normally conductivity does not super dependent on temperatures. For example, for conductors, they will remain conductor even in higher temperature, but their conductivity decreases normally. Okay, insulators will remain insulators no matter what temperature you are operating on. Semiconductors, on the other hand, they have a very particular sensitivity for the temperatures. At some temperature, it will behave as conductor. At some temperature, they will behave completely as insulators. So that is, there are very specific particular type of conductors. We have a completely dedicated chapter for semiconductors. There we will discuss more about semiconductors. okay, including conductors and insulators. Conductor insulators will come back again in semiconductor chapter. There we have to discuss it again. Now let's look into the basic properties of electric charges. There are three basic properties of electric charges. You should note it down, and they are very, very important, and not only in exams, your board exams, they also comes in the competitive exams as well. Okay, first is charges are additive in nature. So charges are additive in nature means if you add two charges, okay, you can add them just like numbers, or on the other hand you can say you can add them just like scalars. Okay, charges can be added algebraically, normal algebra, nothing special. Okay, so nothing special is also a property. You might think that why it is important, because in physics there are a lot of things which are not they are special. Okay, for example, velocity is a vector, you cannot add them simply algebraically. Force you cannot add them algebraically. Even for some of you have struggled a lot while adding the forces, right? You have to remember a lot of laws, but charges are simple. Okay, next is for example, I have given you one example, q minus 2q plus 3q. Now you will say how to add them? Nothing, add positives then subtract the negatives, so you will get the total charge, right? So this is how you should add charges. Total charge can be added algebraically, just like algebra. Okay, charge is a scalar quantity, basically that gives out the final result, that is charge is a scalar quantity and it is not a vector quantity. Okay, charges are conserved. This is the most important property. This is the second most important property. The most important property is we are still to discuss. Okay, so this is the second most important property. This is the third most. So it's least important. We started with the least important property. Next is the second important property, and then will be the most important property for the last, right? So total charge of an isolated system is always conserved. Very, very important. Let us understand the first is what is the meaning of the term isolated. Isolated means it is not connected to anything else. It is separated from rest of the world. Okay, for example, if you are watching this video through YouTube in your own room, your room door is locked, no one is there to disturb you, that means you are in a isolated setup. Okay, so for example, if you go to moon, okay, if you go to moon with your bottle of water, okay, the water available to you in moon is limited to you, right? So we say that total water on the surface of the moon is conserved, right? Now that is a separate thing, how you will survive there. Anyway, so basically as long as you are separate from the universe, total charge of a system will be conserved. That means it will be constant. Okay, but there is a small information to it, that it is not possible to create or destroy net charge. Net charge cannot be created or destroyed. That means if I say that net charge of this object is 0, net charge is 0, the net charge of this object will remain 0 as long as it is not communicating, not touching anything else. Okay, as long as it is separated from rest of the world, it will have Q charge 0. Now you might say that, I know sir, an atom consists of positive nucleus and negative electrons. I have studied in our chemistry class. So how can you say that charge cannot be created or destroyed? I can take electrons, I can take positively charged nucleus. So I can create charges, I can separate them. Yes, you can separate positive and negative, but as long as it is isolated, that means you have taken out the negative charge, but the negative charge is still on the object itself. It is not communicating with anything else. If you take it out, that means the object is not isolated. If it is isolated means even if the positive and negative separation happens, even if the chemical reaction happens, okay, as long as it is isolated, total charge will still be 0. Basically total number of positive and negative charges are equal. That is the meaning of it. Okay, if total charge is 0, that means positive and negative charges will remain same. In case it is already charged, the excess amount of charge will remain constant. Okay, carried out by any isolated system, although the charge carrying particles may be created or destroyed. Okay, charge carrying particles can be created or destroyed. For example, you have only energy. Okay, even from energy you can create positron and electron pair. If you have energy only energy, okay, you have energy. If you have energy only, okay, not electric field, sorry, you have only energy, light energy, like that, heat energy. So from energy also you can create particles. Okay, from in fact the universe created from energy. If you remember Big Bang theory, it was very popular. If you don't know, you can go and Google it and you can study a little bit about it. So it says that our universe created from energy. Okay, and from energy you can create different particles. Okay, so even if you are creating particles, electrons and positrons, okay, E is equal to mc square, that is another formula. So you can create charged particles from energy, but energy has net charge. What is the net charge of energy? Obviously 0, it has nothing to do with charges. But even if you create charges, those charges are also, total charge is 0. Even if you create charges, net charge will be always constant. Now last and the most important property of the electric charge. Okay, the most important property is charges are quantized. This term may be new to you, so I will explain it little bit detail. Okay, all free charges are integral multiples of a basic unit of charge denoted by small e. Okay, all charges are basically multiple of this charge small e. So what is the small e? I know most of you know, this is basically charge of an electron. Okay, and any other charge can be denoted by n times e. Okay, where n can be 0, obviously if the object is neutral. It can be plus minus 1, it can be plus minus 2, it can be plus minus 3. It cannot be say 3.5, okay, or 100.5. These values are not possible. So there was once there was a question, they have given you some charges and said which of the following charges is not possible. So basically that means you have to divide the number by 1.6 and check if it is giving you a integer value or not. If it is not giving you any integer value, that means that charge is not possible. As simple as that. E is charge of an electron and it is given by 1.6 into 10 to the power of minus 19. So if you don't if you haven't yet remembered this value, definitely this is the value you have, the first value that you have to remember. Okay, there is no other option. This is very basic fundamental constant. Okay, so this constant you have to remember. There are few more constants that also you have to remember, but this is the first constant that you have to memorize. There is no other option. There are few constants you have remembered in the past, right? Avogadro's number, right? So this is also one of such constant that you have to remember, 1.6 into 10 to the power of minus 19. Now let us understand what is the meaning of the term quantized. Okay, so you visited a milk shop. And you asked that I want 1 packet of milk. The shopkeeper will give you 1 packet of milk. Now 1 packet of milk contains 1 liter milk, suppose, and this is the now many students will say, sir, there are packets of half liter also, 250 milliliter also. Now for assume that 1 liter is the smallest packet available in the shop for now. Okay, 1 liter is the smallest packet available in the shop. Less than that is not possible, not available. Now if you go to the shop, you say I don't want 1 liter, because I have seen one video in the YouTube which asked me to add 900 milliliter of milk. Okay, it asked me to add 900 milliliter of milk to make some ice cream. Okay, I have seen some ice cream recipe, they have asked me. So you went to the shop and you said, please give me 900 milliliter of milk. He will say, no, 900 milliliter milk is not available. You have to take 1 liter only. Okay, you cannot buy this amount of milk from the shop, right? Even though it is required, you need to minimum buy this 1 liter pack. Okay, if you need say 2.5 milliliter of milk, then you have to buy 3 packets, right? So this is the minimum quantity which is available in the shop. Now in case of milk, you can cut it and you can use it in the smaller portion, but in case of electrons you can't even cut it. So this is the shop. Okay, so in the shop of electric charges, the minimum charge that you have to take is basically E. Okay, if it is 2 charges, then 2 packet of milk, 3 charges, 3 packet of milk, 300 charges, 300 packets of milk. Based on your requirement, you can have only full numbers. Half numbers are not possible. Half numbers are not possible. Decimal numbers are not possible. That is very, very important to understand. Now let's see one question from a little older KCET question, but this is a very important question, because this kind of questions are coming for your board exams MCQs as well. And I will tell you how can you calculate this question faster. That is a shortcut method as well. So first, if a charge on the body is 1 nanocoulomb, then how many excess electrons are present in the body? So this is the first question. So let us solve it in a conventional way. Okay, so we know that any charge can be represented by Q equals to N into E, right? And here what is the charge given? Charge given is 1 nanocoulomb. Nanocoulomb means what? 1 into 10 to the power of minus 9. So you have to remember this. Obviously these terms: nanocoulomb, microcoulomb, milli, nano, milli, micro. Okay, so if you don't know that, nano means 10 to the power of minus 9. There is one more unit, angstrom, is 10 to the power of minus 10. There is another called pico. Pico is 10 to the power of minus 12, and femto 10 to the power of minus 15. These are the smaller. And in the next we have micro. Micro is written like this, 10 to the power of minus 6. We have milli, which is 10 to the power of minus 3. Okay, so these are all the things that you need to remember. If you don't know, just because it's the first lecture, I am explaining it to you. Maybe from the next lecture I will not explain. I will just say nano means 10 to the power of minus 9. Okay, so nano means 10 to the power of minus 9. Now what is the number of electrons? That N we are trying to find out. What is E? E is given by 1.6 into 10 to the power of minus 19. This value we already know. Now what is the value of N? So N is basically 1 by 1.6 into 10 to the power of minus 9 divided by 10 to the power of minus 19. Okay, so it will be 0.625 into 10 to the power of 10. Minus 19 goes up, it becomes positive. So positive 19 minus 9 becomes plus 10. Now if you see the options, none of the options are given like this. So there we have 6.25, 6.25. So what we have to do? We have to borrow 110 from here and multiply it here. 6.25. Now because we have borrowed it from the top, 10 will be less. That means it will be 6.25 into 10 to the power of 9. So correct answer is option D. Now I was talking about a shortcut method. The shortcut method, obviously for shortcut methods you have to remember something. What you can remember is that 1 coulomb of charge is basically 6.25 into 10 to the power of 18 electrons. Okay, 1 coulomb of charge is 6.25 into 10 to the power of 18 electrons. Number of electrons in 1 coulomb of charge is basically 6.25 into 10 to the power of 18. That is the number. If you remember this number, any charge given to you, you can convert it. Okay, nano coulomb, micro coulomb, milli coulomb. Okay, so also they might ask you directly 1 coulomb. Okay, so if they see you 1 micro coulomb, micro means what? Micro means we know that 10 to the power of minus 6 coulomb. Okay, so 1 coulomb means what? 6.25 into 10 to the power of 18. Just multiply it, you will get 6.25 into 10 to the power of 12. Okay, so this is how you can convert it directly if you know the conversion factor. This is called conversion factor. Okay, so this is how you can solve it in exam. Now maybe you are not able to remember it right away because you are just starting your classes. Maybe in your colleges also you are just halfway through your lectures, so it may be difficult for you right now, but as the exam comes closer, you have to remember this value so that you can solve the questions quickly. That is very, very essential, right? Next, these are the results of our Diksha Vedantu. If you are someone who is not very keen or who may not be able to understand directly from our online lectures, you want to take admission in the offline campuses, then definitely you can join our Diksha campuses. You can refer it to your friends and families, and the results of Diksha is excellent in KCET 2025, right? We can see rank 8, 15, 23, a lot of top rankers, top 1 student in top 10 rank, 14 student in top 50 ranks, 24 students in top 100 rank, and 83 students in top 500 rank. So lot of toppers are from Diksha colleges, and you can be one of them. If you want to join our Diksha colleges, please contact our representative. The number for this is given in the description. You can join our Diksha campuses by calling that toll-free number. Now let's start with our next concept, which is Coulomb's law. Okay, so as I said, we will be discussing Coulomb's law up to electric field lines in our class. So let's continue our lecture, Coulomb's law. So the size of before obviously starting Coulomb's law, we have to identify one thing which called point charge. Okay, even though it is very trivial for you, might be thinking, oh, point charge means charge which is a point, but in physics even a point is, you have to define, right? Nothing is super simple. Even a simple point has to be defined. Now what is a point charge? The size of a charge object is smaller compared to the distance. So if you compare an object, okay, if you see this is an object, and the distance from where you are doing some measurement, some experimental measurement, if the distance is large enough, suppose this is 1 millimeter and this is say 100 centimeter. So you can see that compared to 100 centimeter, 1 millimeter is quite small. It is very, very small, right? So even for this object, which is not actually a point object, you can consider this to be a point object. So that is how our physics teachers cheat, right? This is how we cheat. We cheat by approximation. We cheat by approximation, right? So even though the object is actually not a point object, we will say this is a point object because the distance is larger than the size of the object. Similarly, in case of size of the charged object, if the object is charged, okay, that means it has some excess charge. Charged object means obviously all the objects has some charge in it, right? So charge specifically means it has excess charge, either positive or negative. That means either it has excess amount of electrons or it has excess amount of positive charge. That means some electrons are removed from it, right? Now statement, the force acting between 2 point charges. So why the point charge is important? Because Coulomb's law is specifically stated for point charges. So this is, if they ask you what is the drawback of Coulomb's law, you might say that Coulomb's law is not applicable directly for extended objects, for large charged object, right? This is one of the flaw. So the force acting between 2 point charges is, first of all, directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between the charges. Okay, so it is directly proportional to the product of the magnitude, inversely proportional to the square of the distance between the charges. We will explain it a little bit later, but this is the statement and you have to memorize it. Next, the force acts along the line joining the two charges. Sometimes students often forget this line. This is also very, very important. Now, let's continue. So here we have two charges, Q1 and Q2. Okay, they are point objects because even though they are quite big, as I said, the distance between them is quite large compared to their sizes. So that's why we can say they are point charges. So 2 point charges separated by a distance r. Then from the Coulomb's law, we can say that force between these two charges is basically K into modulus. Why we have applied modulus? Because this is the force, right? So force will have a direction. Okay, here we are considering the magnitude. Okay, and by applying modulus, we have ignored any chance of having positive or negative charges. Okay, so positive, it can be Q1 can be positive, Q2 can be negative, but if I apply the modulus, that means we are only taking the positive value. So we are only taking the magnitude of the force, that is, it is always positive, we are assuming. Okay, so it will be K Q1 Q2 by R square. R is basically the distance. So it is directly proportional to the product of the charges. Product means multiplication, and inversely proportional to the square of the distance. So inversely means 1 by. Inversely means 1 by. Square of the distance means 1 by R square, right? And here this is a term that we have used. This K is called Coulomb's constant. This is Coulomb's constant, and it has a weird formula, that is 1 by 4 pi epsilon naught, and its value is 9 into 10 to the power of 9 Newton meter square Coulomb to the power minus 2. Now you may forget this unit, but the value is very, very important. We have to remember this value. Unit is not super important. Maybe they might ask you in the exam, in the board exam, what is the unit of Coulomb's constant, but other than that, and also this quantity, okay, so this quantity unit is also very, very important in terms of board exam or your college exams. They might ask you the unit. Other than that, this value is very, very important. Okay, this value you have to remember it. Okay, now from now on, whenever we will write some equations, especially in electrostatic chapter, two chapters, this chapter and the next chapter, okay, you will often, very often, you will encounter this constant. You will encounter this constant. Okay, and in many equations, many formulas, it comes as it is, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught. Okay, so from time to time I will express that in K in my lecture, so that obviously you have to write it down, type it down, long formulas. In exam also you can use it K, as long as you mention that what is K, and the final expression, suppose you are doing a derivation. In the derivation you have to, each and every line, instead of writing 1 by 4 pi epsilon naught, if you write it K, it is fine, but you have to define what is K. Okay, and at the end of the formula, final expression, you have to put back this value. If you do that, you can use that as well, no problem. Here this epsilon naught is a very special quantity. It is called permittivity of free space or permittivity of vacuum. Okay, same thing, permittivity of free space. Free space means which is free from everything, that is vacuum, right? So permittivity of free space, and its value is 8.85 into 10 to the power of minus 12 Coulomb square Newton inverse meter to the power minus 2. Now this value is optional to remember. Okay, generally the constant values are provided during the exam. If it is not, then it will be given to you as a special value in the question itself. Okay, but if you remember it, it will help you from case to case. Anyway, I will tell you how to remember this value, how to approximate, even if you don't remember, how to approximate this value. Okay, only thing you need to remember, this is 10 to the power of minus 12. That is the important part you have to remember. For medium of dielectric constant K, the effective distance in vacuum will be R root K. Now here we assume that the entire system is kept in vacuum. Okay, this entire system is kept in vacuum, right? Now instead of vacuum, if you keep these two charges Q1 and Q2 in some medium, say water or glass, okay, say glass, and in that case the it will have a dielectric constant. Okay, dielectric constant, and it is denoted by capital K. This is separate and this is separate. If you see, this is a particularly small k, and here I have mentioned it a capital K. Okay, so dielectric constant, we will study about dielectric constant in the next chapter itself, but just for your knowledge, this law is not always exactly it is. If you change the medium, the force also changes. Force is dependent on the medium, that is important. And if the dielectric constant is K, then the equivalent distance will become R root K. So in the same formula you have to put R root K. We will solve some questions in future. We will see some questions based on these expressions as well, but not right now. Right now you just need to remember it. In case you are revising it in future, when everything is clear to you, then you can refer to this note and you can remember it. That's why I have added it here. Other than that, you can just skip it for now. But remember that you have to study it in the next future classes. Now let's see Coulomb's law in vector notation, another very common question. It comes across board exams. So what is the vector notation? Vector notation is when you represent the force in terms of vector notation. So we have two charges, 1 and 2. Okay, we have two charges, 1 and 2. Okay, force on 2 due to 1, force on 2 due to 1 is F21, force on 1 due to 2 is F12. Okay, the distance between them is represented by this. This is the origin. This is the origin. Okay, this is R1, this is R2, and the distance R21 is basically R2 minus R1. So vector notation will be F21 equals to KQ1 Q2 by R square, R21 vector by R. This is very, very important. Okay, so I have seen students they write vector over here, but they forget this R. Okay, you can write it alternatively. You can write it K Q1 Q2 by R cube R21. This is also fine, or you can write it K Q1 Q2 by R square R21 cap. Whatever you are using, everything is fine. But I have seen students they remember half, they forget half. So they write it like this. This is not correct. This is, if you are writing vector sign over here, because you are adding one extra which is not there according to Coulomb's law, you have to divide it by this extra R, and it has to be cube in the division. So if this is F21 from Newton's third law, it will be minus F12. Okay, so these are basically from Newton's third law, action reaction pair. Okay, and in exam, if you see that vector notation of Coulomb's law, the diagram is compulsory. Okay, diagram is compulsory. If they ask you write Coulomb's law in vector notation and explain, so first state Coulomb's law means the statement. Okay, explanation in vector notation means is this, and there the diagram is compulsory. Okay, be careful about it. Next is force between multiple charges. So what is that? Suppose we have a charge over here. Okay, say charge 1. Now I want to find there are multiple charges present in the vicinity. Okay, 2, 3, 4, 5. I want to find what is the net force acting on this charge because of the other charges. So the net force acting, obviously there will be some force. Now if both charges are positive, you have to remember that also. Coulomb's law talks about force. If both charges are positive, the force will be a repulsive force. Okay, if charges are, one charge is positive, one charge is negative, then definitely we know that they attract each other, the force will be attracted. So for example, this is say positive, this is also positive. So the force is repulsive in nature. Now if this force is negative, then what is the force on this? Force on this will be in this direction, attractive in nature. So based on whatever is the sign of the charges, force direction will vary. Okay, force direction will vary, right? So this charge will experience a lot of different forces in different directions. Okay, so what is the net force acting on it? Net force will be vector sum of all the forces. Okay, vector sum of all such forces acting on it will give you the net force. Okay, so here we have F1 is the force acting on our one charge. Force acting on our one charge is given by all the other charges. There may be n number of charges. Okay, starting from 2 till all the way to n. Okay, so starting from 2 all the way to n, and vector sum of all such forces. Okay, so it is very, very important. So whenever you are trying to find the direction of forces, you have to check whether both charges are positive or negative, right? So based on the sign of the charges, the direction of force will change. Now next is very important concept, that is electric field. Okay, so we are going to discuss about electric field quickly. So what is electric field? We have two charges separated by a distance. Okay, so we have two charges separated by a distance. Now this charge is exerting a force, applying a force. Exerting means applying a force on this, right? Now this charge, we are saying this is a test charge. That means it will not reply back to charge Q. It will only experience the force due to charge Q, capital Q. Okay, so this is the big brother, this is the small brother. So small brother is sitting in the corner and big brother is pushing it. Now what will happen to the force? The force value is given by K1 Q2 by R square, right? Now if you remove this charge completely, then what effect of this capital Q charge will be there? The force becomes 0, right? The charge is no longer there. Charge is no longer there means force is 0, right? So actually force is not 0. What we will do, we'll assume that there is a unit positive charge present over here. This is a unit positive charge, and I sometimes call it your best friend. Unit positive charge, because whenever you are in trouble in electricity, electrostatics, you assume a unit positive charge and then try to find out what will happen to that unit positive charge, whether it will be attracted, whether it will be repelled, whether it will move away. So based on that you can do a lot of things in electrostatics. That's why I say unit positive charge is your best friend. Okay, so we have unit positive charge, right? So that unit positive charge, how can we make this charge unit positive? By dividing both sides of our equation by this Q. Basically what we are making this division over here. That means we are basically multiplying with 1 over here. Okay, now this F by Q term is called electric field. This F by Q term is called electric field. Okay, and it is nothing but KQ by R square. So Q is source charge, as I said, and this small q is called test charge. It does not have any effect on its own. Okay, so this is how you arrive at the position of electric field. The concept of electric field is very complex. If you want a discussion on electric field, please mention that in the comment below. I can do a lot of elaborate discussion, but that will not be suitable for most of you, which is obviously beyond and away above your scope of your study right now. But the basic idea is that if Coulomb's law talks about force between the charges, and to have force you need to have two charges. Now if there is no other charge present, then what is the remaining part of that charge here? That is called electric field, right? Now electric field can be represented for a point charge like this. Okay, so this is how you can represent the electric field due to point charge. As I said, this expression, this value will come in lot many cases, and you can say this is like when you visit a temple or you visit some places of worship, you have to apply some tika on your head. So this is like that tika. Okay, so first you apply the tika, then you enter the temple. Okay, so this is how you go to the places of worship. Now different people have different style. They always have something before you enter, right? Either you wear certain clothes or some dress, particular some thick. So this is the thing that you have to do before you enter the temple. So you can consider your physics is like a temple. Now the electric field due to a charge Q at a point in space may be defined as the force that a unit positive charge would experience if placed at that point. So this is how we define electric field. So if we keep a unit positive charge, normally it is not there, charge is not there, but if you place it over here, whatever force it would experience, that force we call it electric field. Okay, so basically whatever is the influence of this charge at this point, influence of this charge at this point is the now there you might get a little confused because last case I was using capital Q, here I am using small q, so let me change it to capital Q only. Okay, I know many of you are saying, sir, the small q was the test charge, no? So let me change it to capital Q. Okay, clear? So basically this electric field is when you place a positive charge, unit positive charge, whatever force it will experience, that force is the measurement of electric field. So everything is related to Coulomb's law only. Alternatively, if a charge Q is kept inside an electric field, now so far we have idea about the source charge. This capital Q is sometimes called source charge, right? So if this charge is well known, you can apply Coulomb's law. Now you don't know this source charge. What is the source charge? But at some distance you know the electric field. You measured it, you have a device, using that you measured an electric field. Now if you place a test charge Q at this point, this test charge will experience a force. This test charge will experience a force. What is the force experienced by then? The force experienced by the charge is given by Q into E. Okay, so basically what we said, this is our nose, this is our ear, now this is our nose as well, right? So we started from force, we went to electric field, now we are coming back to force. Now even though it is, you might feel that it is the nose like that, actually it is very, very important. Okay, because in many cases this source is completely unknown, but electric field is known. Okay, even in fact in more than Coulomb's law, the concept of electric field is much more important. Okay, because in 90% cases, 99% cases, electric field is known. Okay, if you keep some charge at that point, then you can calculate the force. Okay, this is not only important theoretically, this is also important in terms of questions that you might face in your exams. Now let's see one such question. Okay, a charged particle of mass m and charge q is released from the rest in an uniform electric field E. Neglecting the effect of gravity, the kinetic energy of the charged particle after t seconds. This is a mixed concept question, not super straightforward, slightly tricky, but once you have practiced a lot of questions, you can solve this kind of questions as well. Okay, so first let us see, we have an electric field E, we have charge Q, we have mass m. These are given. Now what is the formula? What we have to find? We have to find the kinetic energy. So what is the formula for kinetic energy? If you remember, this was one of the easier formulas, half mv square, right? This is the formula for electric kinetic energy, right? So kinetic energy formula is half mv square. So m value is already given. Now we only need to find V. If we can somehow find V, we can find the kinetic energy. Now how can we find V? For that we have to know that when we keep a charge in an electric field and release it, it will experience a force. What force that will be? That force is Q into E, right? Just now we have discussed. Now this is the force. Now there is one more person who is much wiser than Coulomb, who said something that father equals to ma. Whenever there is a father, there will be also ma. Okay, so whenever there is a force, that force can be written as m into a, right? So what is m? M is mass. What is a? A is acceleration. So by comparing these two, we can say a equals to q into E by m. So we have found acceleration. So now we can see some hope. Okay, we can find what is the velocity. Acceleration is known. So what is the velocity? Initial velocity starting from rest. So initial velocity is 0. So final velocity equals to u plus at. Very old simple formula, not very difficult. Okay, so u is 0, a value is qe by m, and time t is given already in the question. So velocity is qe t by m. Now you have to put that value in our old kinetic energy formula, that is half m v square. V square means everything square, q square e square t square divided by m square. So one of the m will be cancelled. So you get q square e square t square by 2 into m. Right? So if you see, this is the correct answer. Not a rocket science. Questions are simple. Only thing, more than one concept you may need to apply. Right? More than one concept you may need to apply to solve in certain cases. Right? Now let's move on to the next part. So electric field due to a system of charges exist at every point in three-dimensional space. There are few points that you need to remember. So if I say electric field due to a charge or system of charge, it exists all direction, all three-dimensional space, up, down, right, left. Okay, there is no such restrictions. Okay, what else? For a positive charge, the electric field will be directed radially outward from the charge. So if the charge is positive, the electric field will be radially outward. Okay. For negative charge, it will be each point it will be radially inward. If the charge is negative, then electric field lines will be radially. Now electric field lines are basically representing the electric field. Okay, field lines are grammatic representation of the electric field. So when you represent electric field in through diagrams, then these lines and arrows comes. Okay, so basically these arrows represents electric field. Okay, and the representation is called electric field lines. Right? Electric field due to a point charge is spherically symmetric. So if the charge is point, then it is a spherically symmetric. Spherically symmetric means if you draw a sphere around the charge, all the points will have same electric field magnitude wise. So that is what it is called spherically symmetric. When a positive charge is kept inside an external electric field, it will experience a force in the direction of the electric field. Suppose we have an electric field, and if we keep a positive charge in the electric field, it will experience a force in the direction of electric field. Okay, when a negative charge is kept inside an electric field, if you keep an negative charge, it will experience a force in the direction opposite to that of the electric field. Okay, positive charges experiences force in the direction of electric field, negative charges experiences a force in the opposite direction of the electric field. Okay, now let's see one question. Three small spheres, each carrying a positive charge q, are placed on the circumference of a circle of radius r to form an equilateral triangle. The electric field intensity at the center of the circle. So very interesting question. Through this we will cover a little bit of theory, small, and also we will solve a question. Okay, now question is slightly tricky because you have to remember something. So what is the question? We have three small spheres, each carrying a positive charge q, are placed on the circumference of the circle. and the circumference basically forms an equilateral triangle. Okay, equilateral triangle. Now here we have, this is the center, so that means if it is an equilateral triangle, okay, this distance will be definitely radius. Okay, this will also be radius, and this will also be radius, right? Now this is an equilateral triangle, so this angle, this total angle will be 60 degrees, right? This total angle is 60 degrees. Now because it is passing through the now this is an equilateral triangle, right, and this is an external circle passing through all the three vertices. So basically this side, this R will divide the triangle into not only if you extend it, it will not only divide this triangle into equal, the sides will be divided equally, the angles will also be divided equally, right? So this angle will be 30 degrees, this angle will also be 30 degrees, right? And similarly, if this angle is 30, okay, this angle will also be 30, because this is also an equilateral triangle. Now if these two angles are 30, then definitely this angle will be 120 degrees. Okay, so if this angle is 120 degrees, similarly this will be also 120, and this will also be 120. Okay, all sides will be 120 degrees, all angles, which is very, very important to remember. Now if all the sides are all the angles are 120, now let me draw the angles only, this part. We are trying to find the net electric field at this point. Okay, so for that, what we have to do, this is 120, this is 120, this is 120. Okay, now if all the three angles are equal, what you can expect is that if you add these two electric field, this electric field and this electric field, okay, then both are positive, all charges are positive, plus Q, plus Q, plus Q, right? So everything is away, and for this it will be in this direction. Now if you add these two electric field, you will get an electric field which is exactly equal and opposite to this one. You can check the mathematical way how to add two vectors. To add vectors, it will be vector A plus vector 2 square plus 2 E1 E2 cos theta. Okay, this is the magnitude. Now if you put all the magnitude wise, all the electric field is E. Only thing is the angle between these two is 120 degree. Okay, so if you add these two vectors, you will get E square plus E square plus 2 into E1 E2, which is also E square, cos 120. What is the value of cos 120? So that is very, very important. So it will be E square plus E square, that is 2E square, 2E square plus 2E square into cos 120 is minus half. Okay, so minus half, you will cancel, you get square root of 2E square minus E square, which is E square square root, that is equals to E. So this will be exactly equal to this. The magnitude of the addition of these two electric field is exactly equal to, but in the opposite direction. So that's why the net electric field in this case will be 0. Okay, this is not always the case, but this is an easy question. So you can say, because the symmetry of the system here, the net electric field will be 0. Okay, if it's a symmetric system, you have to remember that for symmetric system, electric field is generally 0. Now we have some system of charges. Suppose we have a system of charges Q1, Q2, similar to that previous one, Q2, Q3, Q4, and we want to find electric field at some point. Only difference is, in that case the force was determined by on another charge. Here there is a independent point and we have a system of charges. we want to find what is the electric field at that point. So what we can expect, we have to find the corresponding electric fields E1, E2, E3, etc. Sometimes it can be in the direction also, sometimes it will be away. So based on the point, whatever it is, E1, E2, E3, so you have to add them and find the vector sum of all such electric field. Okay, so here electric field is here, this is the net electric field. Net electric field, after you calculate everything, you get the net electric field, say E. So net electric field is sum of all individual electric fields, and because electric field is a vector quantity, you have to add them vectorially. So in this chapter we have learned that electric charge is scalar, but electric Coulomb's law, Coulomb force is a vector quantity. Electric field is also a vector quantity. So you cannot simply add them. Now properties of electric field lines, very important. So as I said, electric field lines are the pictorial or diagrammatic representation of electric field. Pictorial means picture. Okay, so field lines start from positive charges and end at negative charges. So when we are drawing field lines, it will always start from positive charge and end at negative charge. Sometimes it can start at infinity and end at negative charge as well. This is also possible. If there is a single charge, they may start or end at infinity as well. Okay, so in case of only positive charge, it might end at infinity. In case of only negative charge, it can start at infinity as well. But whenever there is a system of charges present, okay, the electric field will always start at positive and it will always end at negative. Don't worry, this is the last concept. So after this the lecture will be over. I will give you some homework. In a charge-free region, electric field lines can be taken to be continuous curves without any breaks. Okay, so if there is no other charge present, electric field lines can be considered to be a continuous lines. Okay, next is two field lines can never cross each other. This is very important, favorite of the students. Okay, two field lines, they can never cross each other. Very important. Based on that, lot of questions might come. Okay, why not they cannot intersect each other? Because if they did, the field at the point of intersection will not have a unique direction. For that you have to understand that electric field is a vector quantity. So vector quantity has a unique direction at each and every point, right? So unique direction means if you consider this point, direction is only one direction. At the same point, there cannot be a different direction possible. This is not possible. Okay, and electric field lines are basically lines. If you draw a tangent, suppose this is the electric field line, and you want to find the direction of electric field at this point. So for that you have to draw the tangent on that line. Okay, and that tangent will give you the electric field at that particular point. Okay, so if two electric field lines, they intersect each other, then at the point of intersection you will get one direction this side, one direction this side, which is not possible because electric field at this point has a fixed value. Okay, electric field at each and every point has a fixed value. So if it has a fixed value, then its direction will also be fixed, only one direction. So if two field lines intersect each other, then that possibility is no longer there. So that means electric field would have multiple direction. That is not correct, right? That's why electric field lines cannot intersect each other. Electrostatic field lines do not form any closed loop. What is the meaning of closed loop? Closed loop means it starts and if it is ends at the same point, then it is said closed loop. Starting point and ending point, if they are same, then it is said closed loop. But electric field lines does not form any closed loop. So a closed loop is not possible for electric field lines. Electric field in free space decreases as we move in the direction of electric field lines and vice versa. So suppose we have an electric field over here. Electric field at this point, suppose, is E1. Electric field at some point is E2. What is the relationship between E1 and E2? Okay, let me redraw the line slightly. Okay, we have, say, this is the electric field line system. E1 is here, E2 is somewhere here, okay, and say E3 is here. So at what is the relationship between E1, E2 and E3? Okay, so as we are moving in the direction of electric field, electric field decreases. That means E1 is always higher and E3 is in between E1 and E2. So E3 will be slightly less than E1 and E3 will be greater than E2. It does not matter where the point is located as long as it is located inside the electric field. Okay, so this is the relation. E2 will be the smallest, E1 will be the highest. Now these are the homework question. Solve the homework question and mention the answer in the comment below. And obviously if you want to download the PDF along with the notations and the homework, definitely join our WhatsApp channel. The link of the WhatsApp channel is given in the description. Okay, so don't forget to join our WhatsApp channel, right? This is second homework question. Pause the video if you want, solve it and mention the answer in the comment below. Everything including the homework questions will be provided to you at absolutely free of cost. Only thing that you have to do, you have to join our WhatsApp channel. The link of that is given in the description. Don't forget to join our WhatsApp channel. Your identity will be remain hidden. No one will be able to see your contact number, not even us. We will also not be able to see your contact number. Okay, but whenever we are doing some videos, some updates, that will be posted in that channel and you will get the notification. Also all the PDFs etc. we will post in our WhatsApp channel only. So don't forget to join our WhatsApp channel. Maybe the PDF might take, in some cases it might take 1 or 2 days delay, but be assured that all the files will be provided no matter what. Okay, also the entire video series that we are doing, including all the subjects, will be made available in playlist format, so that whenever you are coming and want to watch some specific videos, that will be available in that particular playlist only. So if you have not yet subscribed to our channel, don't forget to subscribe to our channel. Subscribers are very, very important for us. And obviously if you like this video, don't forget to give it a like and share it with your friends, right? I'll be back with 1.2 or the second part of this chapter. Till then, bye.